In today's video, we're going to talk about something very important to C++, and it's called inheritance. And there are many different things and techniques that we can do with inheritance. So we're going to cover inheritance, talk a little bit about shadowing, and then we're going to get into a much more live or practical example on multiple inheritance. And so for this particular video, I'm going to do something a little bit different. I'm actually going to follow in an actual textbook that I've had for a number of years, and I think it's a really good source of information to learn about this. It's Sam's Teach Yourself C++ in 1 hour a day. There are newer versions which cover C++ 14 and 17, but I thought it would be a good idea to go through. Then if you have the book, you can kind of go through the video with me. So I like this book, so I've chosen to use this. And the videos today are going to be a little bit different in the fact that I go through many examples in Visual Studio rather than more of a PowerPoint. There is a little bit of it, but we're going to do quite a bit of examples out of the book, and then we're going to finally get to a more practical example towards the end. In programming, you're often faced with situations where components being managed have similar attributes, differing minutely in details or behavior. One way to solve this problem is to make each component a class where each class implements all the attributes and then re-implements the common ones. Another solution is using inheritance to allow classes that are similar to derive from a base class that contains common attributes and implements functionality. Then you override the base class functionality to implement behavior that makes each class unique. So by doing inheritance, it gives us a lot more flexibility and a lot more logic to what it is we're actually doing. So if we begin and we have this base class, or it's also referred to as a superclass, what happens is we create this hierarchical relationship, and we're able to actually pull from the base class or the superclass attributes that are going to be common through everything that we use. So for example, my children inherit characteristics from me, and they also inherit characteristics from their mother. Okay, so you could consider, for the sake of my children, that I would be the base class. Okay, so we can derive from the base class, and this is also sometimes called the derived class or the subclass of the base. Okay, and in this example, we've got our first derived class, but you can also have another class that also derives from the base class. This picture shows a relationship between a base class and its derived class. It might not be easy now to visualize what a base class or a derived class can be, so try to understand that a derived class inherits from the base class, and that sense is a base class. Just like don't use the word just like. To make understanding the concept easy, think of a bird class. Classes are derived from bird, are class crow, class parrot, or class kiwi. A class bird would define the most basic attributes of a bird, such as is feathered, has wings, lays eggs, can fly, and so on. Derived classes such as crow, parrot, or kiwi inherit their attributes and customize them. For example, a class kiwi that represents a flightless bird would contain no implementation of a fly function. So if we look at this table here, we've got a fish. Okay, and the derived classes for fish could be goldfish, carp, tuna. And what's important to understand is that these derived classes, they have that relationship that is defined by is a. So a carp is a fish. tuna is a fish. Okay, if we look at some more examples of base classes, a mammal, okay, which is a human, elephant, lion, platypus. And a platypus is a mammal. And a bird, crow, parrot, ostrich, kiwi, platypus, and a platypus, as it turns out, is a bird too. And you've got shape, which is circle, polygon. Polygon is a shape. And finally, polygon, you've got triangle, octagon. An octagon is a polygon, which is a shape. Okay, so you're seeing different examples of inheritance. But one thing I really want to point out here is that, you take a shape, for example. I can't say to somebody, hey, go get me shape. Okay, go pick up bird. Okay, it's always is a specific type of a shape. It's a specialization of a shape. So when we talk about the word class, it means classification, which is classification of a base class. Okay, so if I say I'm going to create a shape called triangle, okay, triangle is a classification of a shape, which is the base class. Okay, so we inherit all of these attributes from the base class, even though technically the base class doesn't really exist. It just has characteristics. Okay? What these examples show is that when you put on your object-oriented programming glasses, you see examples of inheritance in many objects around you. Fish is a class of a tuna because a tuna, like a carp, is a fish and presents all fish-like characteristics such as being cold-blooded. However, tuna differs from a carp in the way that it looks, it swims, and in the fact that it is a saltwater fish. Thus, tuna and carp inherit common characteristics from a common base class fish, yet specialize the base class attributes to distinguish themselves from each other. So there's that word specialization again. Okay, so if we look at another slide and we break this down a little bit further, we see that fish, okay, is the base class, and tuna and carp are subclasses. So they both can swim, but the tuna swims fast and the carp swims slow, but they both lay eggs. Tuna is a seawater fish and carp is a freshwater fish, but they both inherit attributes from the base class fish. A platypus can swim, yet is a special animal with mammalian characteristics such as feeding its young with milk. It's got bird characteristics because it can lay eggs, and reptilian characteristics because it's venomous. So you can imagine a class platypus inheriting from two base classes, class mammal and class bird, to inherit mammalian or avian features. This form of inheritance is actually called multiple inheritance, which we're going to discuss later on in the video. So I just want to really quickly look at the syntax of inheritance. Okay, so how would you inherit class carp from class fish, or in a general class derived from class base? So what we have here is something very easy. I've got my base class and I've got my derived class. But if we look at the syntax to this, I'm going to use the access specifier. You see that it's just a colon, and then the name of the actual class that I'm inheriting from. Okay. So in another example, we look at class fish and class carp. If I want to inherit the fish class members, I'm simply using the access specifier, the colon, and I'm going to use the word public and the word fish. Okay, that is the base class. So let's go over to Visual Studio and have a look at a real example. So what we have in this example is we start off with the base class fish, okay, and we've got a class tuna and a class carp. And like I mentioned before, we use the access specifier, we use the keyword public, and we inherit from fish. Same thing with carp, is that we're inheriting from fish. So both tuna and carp are inheriting from fish. So that means that anything that fish has as an attribute or as a function can then be used by both tuna and carp. Okay, so what you see in this is I've got a flag here, a boolean, is freshwater, and I've got this swim function. So right off the bat, it implies that both tuna and carp can swim. Okay, so any attribute or method that I have inside this base class that I'm deriving from is automatically inherited within tuna and carp. So what you're seeing here is this function called void swim, and there's two conditions for this freshwater. Okay, so if it's freshwater, it swims in a lake. If not, it swims in the sea. And so you see with tuna, it says is fresh water. No, tuna is not freshwater, it swims in the sea. Whereas carp is a freshwater fish. So if I come down to my main function and I look at, I've instantiated my lunch and my dinner, both out of tuna and carp. So if I run this code, what you're going to see is that both my lunch, which is the carp, can call the function from the base class. My dinner, which is the tuna, can also call this function out of the base class. Okay, so if I go ahead and I run this, you can see that the program outputs about my food. Lunch, which we said was carp, swims in a lake. Dinner, which we said is tuna, swims in the sea. Okay, but you have to realize that neither one of the tuna or the carp had written their own specific swim functions. Okay, they got that swim function, it all came from the base class that they inherited from. One other thing that is really important to mention at the moment is the access specifiers. Okay, right now we're set to public. Okay, we're also set to public up here for our member variables. But just be aware at the moment that everything is being set to public. Okay. Base class initialization, passing parameters to the base class. So what if a class were to contain an overloaded constructor that requires arguments at the time of instantiation? So how would a base class be initialized when the derived class is being constructed? The clue lies in using initialization lists and in invoking the appropriate base class constructor via the constructor of the derived class as shown in this code example. So what you see here is that in my base class, I've got an overloaded constructor, int some number. And when my derived class inherits from the base, you see that I am just basically passing a parameter into that base function that is overloaded. So you can see there it says initiate base with an argument of 25. Okay, so all I'm doing is I'm passing a parameter to my base class. Okay, so that's the simple syntax for that. It's not overly complicated. Okay, so let's go see if we can find a practical example in Visual Studio. We're back to the same similar example that we had earlier. So we have our base class fish. We've got this overloaded constructor here for fish. Okay. And we also have the fish function. Down below you see in tuna, I'm inheriting from fish. And tuna has its own constructor. But what you see here on line 29 is that I've got a parameter that goes into the actual fish constructor. So this fish constructor is actually this right here. Okay, the way I've written this. So I still have the original swim function, but I've added this fish constructor. Okay, and I've done the same thing down with carp. And if you look again down in main, there's really no change to what I'm doing in main. Okay, the only difference is that I'm passing this overloaded constructor. This mechanism can be quite useful in class fish, wherein by supplying a Boolean input parameter to the constructor of fish that initializes fish is freshwater fish, this base class fish can ensure that every derived class is forced to mention whether the fish is a freshwater one or a saltwater one, as you see in the example. So if I do actually run this code, it should look identical to our last one. And it actually does. So about my food, lunch swims in the lake, dinner swims in the sea. So it's the same thing, but I'm passing that parameter into my constructor of my base class. Okay. Now, something that I do want to mention right now is the fact that I have changed this to protected. Okay, so my Boolean here is an actual protected member of the fish class. So fish now has a constructor that takes a default parameter initializing fish is freshwater fish. Thus, the only possibility to create an object of fish is via providing it a parameter that initializes the protected member. This way, class fish ensures that the protected member doesn't contain a random value, especially if a derived class forgets to set it. Derived class tuna and carp are now forced to define a constructor that instantiates the base class instance of fish with the right parameter, true or false, indicating freshwater or otherwise. Okay, so I want to write a little, or make a little note here also that you see this Boolean member variable fish is freshwater fish, which is our protected Boolean on line 8. It was never accessed directly by a derived class, in spite of it being a protected member. This is a variable set via the constructor of fish. To ensure maximum security, if the derived classes don't need to access a base class attribute, remember to mark the attribute private. Okay, so therefore a superior version of this code that is now different from the last one that we looked at would feature the we would set that to actually as private. Okay, but in this case we're going to get away with leaving it as protected. So in this example we're going to talk about a derived class overriding base classes methods. So if a derived class implements the same functions with the same return values and signatures as in a class base it inherits from, it effectively overrides that method in class base, and we're going to look at this, how this is done in code. So if we have our base class and our function void do something, okay, and we have now our derived class, which is also do something, okay, thus if method do something were to be invoked using an instance of derived, then it would not invoke the functionality in class base. So essentially what this is saying is I've got two functions and they're both called do something. And because I'm inheriting from base and it has a do something function, but derived also has a do something, what this is saying is that it's not going to utilize do something from base if it has its own version. So if you have a function that is the exact same signature, then it's always going to pick up that local one with some exceptions. You notice here, this is what I'm talking about. The base class fish has the function swim. But as we get down here, we notice that tuna also has swim and carp also has swim. And when we get into main, you'll see that we've instantiated these objects for carp and tuna and it just will demonstrate that the fact that the carp will pick up this swim function here, and tuna will pick up this swim function here. And so there's no expectation that this is the function that's going to actually be called. Okay, so let's run this and look at the example. So here you see that carp, which is my lunch, okay, can swim really slow, which is expected. Then you see that tuna swims really fast. Okay, so nowhere do you see anything about swimming in a lake or swimming in the sea. Okay, and that is because all three of the classes have the exact same function signature of swim. So there are two scenarios that I really want to quickly look at, and then we'll get into an example again in Visual Studio. But one of them is invoking overridden methods of a base class. So in this particular example, we see that carp, my lunch, and tuna, my dinner. My dinner is invoking or calling the swim function from tuna. But you see on the next line, I can also invoke the swim function from the base class fish. And the way I'm doing this is I'm using my dot operator and I'm calling the base class and using the scope resolution operator to specify which exact function I want to call. Okay, so that's one scenario. And this also has something to do with shadowing. So you might want to pay particular attention to shadowing because it's going to come back. And let's go look at another example of invoking methods of a base class in a derived class. Okay, this too also involves this idea of shadowing. Okay, so if we look at this example here, we've got our carp class, which is derived from the base class fish. And if you look down in the swim function of our carp class, you'll see that it's printing out this statement, but it's also simultaneously invoking the swim function from the base class fish. So there's a swim function inside of another swim function. So let's get into Visual Studio and see how this works as well. So you see from this example here that we have our class fish again, tuna and carp. No real change there. We've still got the swim function from our base class fish. And down here in carp, we've also got the swim function, but we're also using the base class swim function. And the reason we're able to do that is because we have this scope resolution operator that's allowing us to do what we're doing here. Otherwise, it would have no idea that we're trying to invoke the fish swim function. Okay, and then if you look down on line 58 again, I've got my dinner dot fish, and again the scope resolution operator in order to call the base class fish swim function. Okay, so up in line 55, I'm just calling the carp's swim function, but on 58, I'm calling the base class's swim function on the carp itself. Okay, so make sure if you're looking at this or you do it, this is not a single dot. You have to use the scope resolution operator because fish swim is out of scope, and that's why it's called the scope resolution operator. So it resolves this and gives you access to that. So the next thing we need to talk about is the order of construction. Okay, and we'll obviously talk about the destructor as well. So when you create an object of class tuna that derives from class fish, was the constructor of tuna invoked before or after the constructor of class fish? The base class objects are instantiated before the derived class. So the fish part of tuna is constructed first so that member attributes, especially the protected and public ones contained in class fish, are ready for consumption when class tuna isn't instantiated. When an instance of tuna goes out of scope, the sequence of destruction is the opposite of that of construction. So we're going to look at an example of that as well. But to demonstrate this sequence, I think it is the best thing to do is just to get into Visual Studio and have a look. So in this particular example, what we have is this fish dummy member. It's a new class. Okay, it has its own constructor. And what it's outputting is fish dummy member constructor, and then the destructor here is fish dummy member destructor. Okay, and then we get to fish, and fish itself is instantiating a dummy object from fish dummy member. Okay, and that's protected. And then fish itself has its own fish constructor and fish destructor. Okay, and then finally tuna dummy member constructor, destructor. And you'll see that this dummy member, it's not inheriting from anyone else, but tuna is inheriting from fish. And tuna dummy member is instantiating dummy. Okay, so it seems like I'm just going in circles here, but you'll understand what's happening in a minute. But each one of these, this tuna has the constructor and the destructor. Okay, so just to really confuse you more, fish dummy member, fish has an object of fish dummy member. Tuna dummy member has its constructor and destructor. And then tuna is inheriting from fish all the way here. It's got a constructor and a destructor, and then we finally get down to main. Okay, and all I'm doing is I'm instantiating my dinner from tuna. So when I run this code, we'll go through what the result is. So the point of this code is just to show you the order of instantiation, or the order of construction and destruction. So you'll see here that my fish dummy member constructor, fish constructor, tuna dummy member constructor, tuna constructor, tuna destructor, tuna dummy member destructor, okay, fish destructor, fish dummy header destructor. Okay, so we went construct, 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 then destruct, 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 and destruct. Okay, so that's what's happening there. It's just to show you which one is actually, what is the order that it's doing it. Okay, so fish dummy member was constructed first, then fish constructor, then the tuna dummy member. Okay, then we got into destructor. So we went in the reverse order, tuna, then tuna dummy, then fish dummy member. Okay, so it's important that you understand it's constructed first in the order that it appears, and then it's destructed in the exact opposite order of what it appears. Okay, so I think we can finish off with that example. I think you understand how that is. It's a bit of a painful example to go through, but it's an important one for demonstration purposes so that you understand what's going on with constructors and destructors and the order that they're actually happening. So we discussed earlier that we were also going to talk about multiple inheritance today. And what you see in this diagram simply again is your base class being a superclass, and then your two derived classes in this particular case. So the way we call upon our multiple inheritance is we've got this access specifier for base 1, okay, and another access specifier for base 2. So the way this diagrammatically looks is that we're going to invert this a little bit. So you see here this, we're talking about the platypus, which turns out in nature is an entirely freaky species of animal. Okay, so class platypus, it inherits from 3 different classes. Okay, it inherits from mammal, it inherits from bird, and it also inherits from reptile. What you're seeing here is this first attribute. This is just defined, it's specific to platypus. Okay, it's not part of the other three classes that it's inheriting from. So we can say on its own, platypus, it can swim. But then it also inherits from the other three classes. So it feeds their young milk, it's covered in hair or fur, it lays eggs, has a beak or a bill, webbed feet, and it's also venomous. Okay, so this is a form of multiple inheritance that I think is unique to C++ and maybe a few other languages, but it's really, really good in the fact that you don't have to keep recoding all of these attributes or functionality that you know exist in other classes. Okay, you can just basically go over and borrow all the functionality. So that's a really powerful thing in C++ when it comes to expanding the amount of functionality that you want to have for your application. So in terms of syntax, what we're looking at is we're starting off with our class platypus, but we want to inherit from the other classes. And the way we do that is we go with our public mammal, we add the comma, and then we do public bird, and again another comma, and then public reptile. Okay, so by doing this, this is the syntax for doing multiple inheritance. Okay, so by now doing this, this is how we get access to all of the different attributes and functions from mammal, bird, and reptile into the platypus. Simple syntax. So I think now what we'll do is go over to a Visual Studio example. Okay, so we have class mammal, and it has this function, feed baby milk, bird is lay some eggs, and spit venom for the reptile. Okay, so now we've got the declaration of our platypus class, and we're just saying public mammal, comma, public bird, comma, public reptile. And by doing that, we now have full access to all three of these functions within the different classes. So if I go down to my main function and I say platypus real freak, real freak dot lay eggs dot feed baby milk dot spit venom and dot swim. I want to highlight that swim only appears inside the platypus class. Okay, there's no swim function in the other ones. Okay, so if we look at this and we run this, and you can see from the output what's happening here is that bird lays eggs and I'm lighter now. Mammal baby says glug. Reptile, I can spit venom, and platypus, I can also swim. Now it's important to fully understand that all of those came off of the platypus object called real freak. Okay, so it's a great example of multiple inheritance. So I think now would be an appropriate time to get into a much more practical example. And we're going to return back to some old familiar code from previous videos. So we've got this class called person, and we'll call person the superclass, and we've also got class employee. Okay, and they're going to inherit from the superclass or the base class person. So let's get into Visual Studio. So I'll run you very quickly through all of the different files that I have. So I have this class person. This is going to be our base class, and I'm initializing this n value. And it's a char person n+1, and then I've got a set function and a display name function. Okay. If I go to my implementation, you see what my setter function looks like. Okay, and I've got this note here that this is the base class. And then when I go to employee, okay, I've got this other thing that I'm initializing, this m to 13. But look here on line 6, you're seeing that employee inherits from person. So what that effectively means that everything that is inside of person is now also inside of employee. But employee further subdivides into employee number and the section that they work in. Okay, here you see on line 12, I've got my constructor. Line 13 is a 2-argument constructor, but you'll notice here that this is a display function. Okay, so the last one is called display name, but in here for employee, we have display. So if I look at the implementation of these, you see how I'm setting up my employee, okay, putting it to a safe empty state. I've got my 2-argument constructor, okay, and I've got no validation logic in here. And then I've just got a simple display, okay. And then when I go to main, all I'm doing here is I'm initializing or instantiating Tom to 123A. And then I'm just calling the various functions. Okay, so Tom is calling the set function. Okay, and so Tom is calling the set function over here in person. I'm calling this function, and I'm also calling this display. Okay, so that's implemented in this way here. Okay, and then I'm calling the display function from employee, this one here, and then that's it. Okay, so you'll see that I'm inheriting from the class person in both the first line 9 and 10. Okay, and then I'm going to make some modifications to this, and then so let me just go ahead and start this. So as expected, I've got this line Tom 123A. Okay, that's what I was expecting out of this code. Nothing complicated. So let's go have a look at a couple of things here. Inside this code for employee, you'll notice there's nothing here in the implementation from person. Okay, and I don't have anything in here either, but I am inheriting from person. Okay, same thing, there's nothing from employee inside the base class. It doesn't work that way. And I'm just creating an object and I'm setting those. So there's another thing that I can do, and I'm going to come back to this idea of the shadowing, okay? And you see that I've got this display function here, and over here in the person, I've got display name. Okay, but when I get to my display function in the employee class, and you remember we're inheriting from person, so anything that person has, employee also inherits as well. So I want to drill down into the display function here and notice that I'm able to actually call this person display name, which was this function here from class person, from the base class. So because I can use the person with the scope resolution operator, I can actually call that function. And notice I'm actually calling that function inside another function, the display function from the employee class. So I'm calling a function from another class inside my current class. Okay, so if you look at another example, I've created employee Tom, and then I'm saying person Madeline. Okay, so I can set Madeline's name to Madeline M, and then I can display the name. Okay, so when I go and I run this, so what you're seeing in this output is Tom first, okay, from the display name, and then Tom 123 and in section A from the display function here on line 11. Then we go down and we're setting Madeline M, and we're just displaying that. Okay, so we're getting what we expected that we would get. And again, it's because I'm actually able to shadow this display name function inside my employee display function here. Okay, and this is all made possible because we've included this employee.h, and in the h file, this is where we are creating the linkage between employee and person in terms of inheritance. Okay, another thing to note is because I'm inheriting from person, you don't see me define any of the functions in the other class. Like set and display name don't appear inside of this. They're already implied to be part of that because I'm inheriting, therefore it already exists. Okay, so it's important to understand that this is now a blended class. Employee is a blended class between itself and also person. Okay, so we've actually covered quite a lot of stuff today, but it's a much shorter video than typical. Very, very basic stuff, but highly important. It's not difficult to implement inheritance or multi-inheritance or anything like that, or do shadowing, but it's extremely powerful that you can do this. Okay, so I encourage you to do some more research and to do some practicing with inheritance. Really powerful tool, and you probably have been using it a lot without even probably knowing it. You've just had the benefit of inheritance from some other classes that you've probably been calling. And I guess the one that comes to mind was probably IOStream when you're including it, or maybe doing an include on string or something. You're probably inheriting inside of those library files and you don't even know it. So I encourage you to dig a little deeper on inheritance, do some practice, but it is an extremely valuable tool to have, and it's a very big component of object-oriented programming. So anyway, I'll leave it at there. Thanks for watching, and we'll see you in the next video.